So we'll be in active two halves. I'll get on to start, then we'll go through the Kope platform and the system there, and then Tom's going to go through the Saint-Gobain process and bits and pieces on that. Just before I start, can I get a show of hands? Who have we got building operators and owners in the room? Manufacturers? Project teams, construction managers and the like? Design, engineering, anything of that space. Okay, cool. Just so I'll tailor it as we go through. So just to give you a bit of background on who we are at Kope. So Kope, the kit of parts engine, that's what the acronym stands for. We're a software platform. So we're an online software platform dedicated to off-site construction products and systems. So it's the first of a kind, very much focused on understanding those limitations and problems that off-site manufacturers and construction teams have getting into projects. Where we come from? So originally, design tech, they were computational experts, understanding, coming from an architecture and engineering background, understanding how these systems and parameters in the BIM world came together. That company was acquired back in 2018, and they really relaunched as a specialist construction ASC plugin software expert. And we'll go through a little bit of the background on where we came from there. But in that journey, what we realised was a number of customers were asking the same thing. So rather than building one-off bespoke solutions for each of them, what came out of that was a Kope platform and a dedicated software solution for the industry at large, asking similar but varying questions of what that need to get into the system. So where we began? We actually began with volumetric. So we actually worked with one of the big manufacturers in the UK on the volumetric space, and one of the challenges they had is every design change that they would have thousands of drawings that need to be reproduced to get onto the factory floor. So if you change a bathroom layout or a kitchen layout, all of that drawing information, machine files, the code set that to go with that, had to be reproduced, and that was taking their design team up to 5 months to reproduce all that information. And within that, you can imagine plenty of issues were coming up, supply chains were changing, tweaks and that. So what we were looking, so what the team did was taking that BIM, that holistic walls, floors, systems as a logic, and actually getting it down to their individual parts so they could go through the manufacturing floor. Little video here. What you can see is, tool by tool by tool, working through one system, one product at a time, starting with that core metal chassis, working through and applying boarding, plasterboards, having to know exactly where all the screw runs were going, the nail fixings, the lot. And the team would basically go through with that manufacturer and work out system by system, understanding the wastage, trying to optimize those boards and pieces, and running through that process. And we would ask the same thing. So another company, another volumetric manufacturer is asking for something similar. They're asking, can we produce drawing sets and machine codes again with these design changes in a way that massively reduces the time to get there. So that, from there, is how Kope was spun up. So we asked, how can we apply this across the industry? How can we look at all of the tools and the systems and the products and actually apply the same logic and thinking that we were doing on a chassis, but to the building form itself? Moving away from just the volumetric approach, but into 2D panelization, into 3D printing, etc., and how can we grow that into an offering? So what came from that is what we call the Kope configurator. It's a dedicated configuration platform allowing you to select the products and systems that you want to apply to your building, understand it, how that building works, how it operates with windows and doors and floors and beams, and allow the products that go into that building to actually be manufacturable and constructible. So moving away from just the world of BIM, which is a data-rich object, but actually the adjacencies from one object to another, understanding that relationship and knowing the limitations on site. How heavy can a panel be before this just becomes unlivable? You can have a board or a panel that is of a certain size, but we are selling 120 kilos. That just isn't manufacturable by 2 people on site. Actually, you need to constrain it and understand the wider inputs and values that come into that. So what is Kope? There's 2 sides of Kope. There's the Kope marketplace, which I'm not really going to go into today, but it's an enormous directory across the UK and Ireland and North America of all of the off-site and pre-manufactured products. On there, we've streamlined and aligned parameters and values between the systems across the building sectors, so you can go on there and find all the different systems that you potentially want to have for your project. And then we have the configurator. Folks that we work for, Mr. Saint-Gobain in British Gypsum, Langer Rorke's, Barton Mallow, who are a big GC out in the States. These are the types of firms that we're working with. So understanding their catalogue of products that make sense, that apply to offsite construction and MMC, and understanding how can we get their portfolio of products onto Kope and onto projects so we can move the industry forwards. But how do we get it? So in order to achieve that, we had to really dig into the building logic and the products that are being applied. You can't just take a standalone isolated system. You need to understand how they work across systems and across products. If you're doing a 2D internal panel with a 3D volumetric shell, what is that interfacing logic? How does a 2D panel interface with a window or a door, a floor, ceiling, etc., etc.? So we really broke it down into its parts and systems. We understood how these pieces come together. It's a system. It's not a one-off product that stands in isolation. It works with the pieces and parts around it. How does a stud or a track relate to a jamb or a sill? We had to dive deep into the building logic. And that is what we call the Kope engine. So we dig into the building itself. We understand building logic and systems. We come from industry. The vast majority of the team come from an architecture and engineering background, but have transitioned to software development. So we understand how buildings are designed and come together. We have construction and manufacturing experts in-house. These are the teams driving this forwards. So everything we build is rooted in industry understanding. It's not a hypothetical application and trying to make it work on site. We spend a lot of time understanding this logic. So with the interval team, we understand how boarding and systems go together. We understand that you can't share studs for fire. We understand how slam tests need to be done, so you have to have clearance for boarding so those things don't break when someone slams the door or the wind catches it and that sort of thing. And we encode that and bring that into the system and logic so those pieces are understood. We go right down to the studs and the screws and the fixings to understand spatial arrangement. You can't have two studs that are too close together. It's just non-buildable. We end up with a coordination issue on site. We understand how MEP works. You bring in a pre-manufactured panel, you really need to understand what you're doing with your MEP and services to make sure that you're not having to do abortive and redo work on site. There's all of these pieces that come into the platform. So one of the workflows, a typical workflow, is you've got the building design team and the operator and the manufacturers. So the construction team, the manufacturing team, the design team, you work in tandem. You go through an iterative cycle backwards and forwards. And once that is agreed and signed off, it goes through to manufacturing. And it tends to be at this point, where it then goes into manufacturing, that a lot of the problems come up because they haven't had industry insight, they haven't had the feedback from the teams because it's taken too long to go through those design iterations, that you end up with problems. This panel actually can't be manufactured, it's too heavy to lift. Or when we try and turn it over, it's cracking because of the shears. So actually bringing that manufacturer's info into the design process, you know that what has been designed is not going to have abortive work as it goes through to production. And what that looks like in a day-to-day is a Revit platform into Kope, backwards and forwards during the design process, informed by the team, informed by an interval and the Saint-Gobain team telling you, actually if you rationalise your design, if you move a door by a couple of inches to the right, you can increase standardization and make that a better solution on site. Actually, if you move your MEP services, or actually rationalize the ducts from 175 to 150 mil, again, you can improve the workflows. And that can then go through into the manufacturing production systems, things like Tekla, SolidWorks, and Inventor. That info continues through. And it's not a start again, which we typically have in the industry, is you get a nice set of PDFs from the architecture and engineering team, and then the manufacturers start again, and they overlay, they redraw, and you have weeks, if not months of delay whilst they're trying to get that up to scratch for manufacturing. So yeah, typically, BIM information Revit model into the Kope system to understand how we're going to panelize and break up that building, down into the subcomponents and parts ready for rolling routine. So, quick little overview of how the process works, and we're going to jump into the case study with Interval and Saint-Gobain. Typically, a project team will upload a model. They'll take their project as early as design development concept stage. You've got some apartment layouts, you've got 10 floors of the building. that is the best time to start engaging with an on-site manufacturer. They can help the design teams, inform them. Some of the small tweaks that make big impacts downstream, the earlier you can get engaged with teams, the better. Rather than late stage 4 under RIBA, we're trying to now shoehorn in a pre-manufactured system, and you come with all of the problems of basically taking what you were doing on site, inside into the warm and under the roof, but you still have all the same coordination problems as before. Actually, starting as early as possible if you can reap so many more benefits early on. That project comes into Kope. We rationalize the design based on that system that you're looking at, and it will inform you, as designed, this is your outputs and metrics. Some small tweaks, door tweaks, wall location tweaks, and we're talking inches and millimeters here, can have this amount of impact going forwards. Get your quants, get your bit of materials, get that information out, inform the design process, and continue on. So that can come back into the design, or once you're further down the project, that can push into manufacturing. So what that looks like with Interval and Kope. So we started with floor plan. You start with the building, you've got the general layout, walls, floors, doors, that sort of thing. What we don't want you to do is start from scratch. Approaching a Saint-Gobain, approaching Interval and saying, here's my PDF, can you guys just draw out your panels on top of the process so we can see what the metrics are. That can take a couple of weeks for an experienced draftsman to sit there and actually go through, well, even an experienced modeler in BIM, it can take them a week to take that base model, go through the RFI process, try and understand, to find out that system's not even the right system for the project, so it took so long to go through there, it's a waste of time. What we do is we take that model, we apply those panels, so we apply Interval to that building rapidly, and we can immediately see where we have concerns. So actually your floor to ceiling heights here are larger than what the panel system can actually support out of the gate, and they have to be a bespoke solution. Actually, you've got a congested corner around the core. You've got 3-4 corners coming together in close proximity. Actually, the panels can't be installed in that way, so you're going to have to go with the traditional frame in that area, but the rest of your building is optimized for that. Once we're agreed, we can go down to the subcomponent level. We need to understand where switches and sockets and MEP services are going to go, and we can coordinate design out of the gate. So before you've even got to site, you've got a digital twin. I hate that word, but you start getting into the digital twin process, and you can start to see we've really got the irony, right?
Yeah. Have you spoken to Mum this morning?
Yeah. She was very proud. And we can get into this process where suddenly we can actually foresee those issues coming through. We can see you've got a wire weight here, you've got pattressing here. The panels are going to work. The panels aren't too heavy for a team to install. The stillages where these panels come together, they can actually be lifted by the crane, and the load locations can work. So suddenly this granular level of detail, informed by manufacturing and construction, can help the design teams actually deliver a better and faster project. So a small animation here. I'm actually going to fly through this and just speak over the top. I think we've got a slightly more detailed one in Tom's presentation in this. But this is Kope. This is it on the browser. Effectively, you upload your model into 3D. You select the system on the left-hand side, the internal partitions, and the configuration and solution that you want to apply. Kope will then apply it in real time. We'll not sped this up. And you can see on the right-hand side are the KPIs and metrics for that system. So how many panels, how many types, how many studs and channels are being used, and what the wastage is and carbon input. So we can go into that. I'm sure there's some EPD experts here, but I'm not going to dig into that too much today. But you can see we're understanding the core logic of how those frames and studs are coming together at a low level of detail, and we can make sure that we're not going to have any coordination issues. From there, we can really dig in. So we can start going through all of the values, the profiles, how many you're going to have in each system, base tracks, head tracks, what orders are coming through, how many boards of what type you need to pursue. From here, we can then go through the optimization process. We'll actually say, I think these parameters can be tweaked. Maybe the minimum, maximum board width. Maybe we can try a couple of different boards, and maybe we can test a couple of different profiles and gauges. Let Kope run dozens, if not hundreds of scenarios at the same time, and come back with an optimization that tells me of the 100 scenarios run, these 4, apples or apples, are the ones that you and the design team want to take forwards. Some of them have an increased standardization, but there's more parts. This one has fewer parts, but they're not as optimized. So you've got a few more types than what you originally had. So manufacturing team, are you happy to run 4 times the amount of bespoke panels? Or do you really want to be running more standardization, etc., etc.? And the team can come to the table very quickly and run different scenarios together. Interval and Kope. So last 2 years, I think it is now, we've been working with Saint-Gobain and the Interval team to really bring that product logic into the platform and seeing some fantastic results through here. So this case study is Wembley Park over in London, 50,000 square foot, mixed commercial, residential space over there, over retail on the ground floor. You can see the size of the project is huge. We're talking dozens of floors. It's not just 1 or 2 typical floors. This could be, the largest projects I've been running is 65 floors out in the Middle East. That one does push the limits on what the tool can do, but it will run. We then have the system being applied, and as I say, we run dozens of scenarios to work out what is the best panel placement and configuration for that project. And these panels arrive on site and get installed. We've got a couple of metrics to come through. But effectively, we've got your internal wall system, your party wall system within Interval. So for those who don't know what Interval is, Tommy, you come into what Interval is.
Yeah, a bit.
Yeah, okay.
Not a huge amount.
So the Interval system is a pre-manufactured partition system. It's your studs and boards, pre-manufactured on site, delivered in stillages, and erected panel by panel. So rather than on-site stick build, you're pre-manufacturing the panels. There's very, very little wastage on site compared to traditional, and the install speed is significantly faster than the guys and gals having to do it panel by panel, stud by stud. And we'll come into what those metrics really look like in a second.
Can I ask if that's what Saint-Gobain do? You manufacture the partitioning system?
Yeah.
Okay.
What we're able to do is we're able to give the install team and the actual construction team an installation process. So this panel goes here, that panel goes there, here's your install sequence. And the system itself can be retrofit if there is something unexpected, we can take it down. Obviously you want to avoid that at all costs, however, it does happen on site, but that can still be done. But what we were doing with the Kope tool was understanding what is the best way to install that from the installer's feedback, from the manufacturing team. As we go through, you can get 4 apartments on 1 lorry load on this project. The team have been manufacturing them in the Saint-Gobain off-site solutions factories. You can see there's a team there manufacturing these. We've got the rigging systems that go through this. So obviously, the more standard panels you can get through, better. But they have the bespokes, where you do have constraints between one door and another. You have to have a bespoke size because of fire rates or architectural clearances and that sort of thing. These things are then loaded up into stillages. So the number of panels loaded up into these yellow stillages. These are lifted onto site, and as I say, that's 4 apartments on the 1 lorry load. Those stillages will come up, loaded in, and once they're done, the stillages collapse down into a heap, and they go back to site, back to the factory, and they can be reloaded again with more panels.
It's worth saying why we've got those pictures up. It almost gives us a stage of production. You can see the first pictures were very much people working around timber jigs. Second pictures, we're getting into automated jigs. And the third process, when we get to the scale we need to, will be investing in full automation. And all of that is tied into the Kope system to generate scale and standardisation, so we can really start to productionise. Terrible word, I know it's but it's start to get that process working. So
it's a real word. But to give you some real metrics and comparisons, so what was fantastic on this project, obviously it's a similar floor plate as you go through the building, your apartments are the same layouts. The install team are actually able to run traditional on some floors, Interval and panelized on another. If you look at these metrics here, this is actually the number of days to install per floor. So traditionally it took 98 person days to install that floor plate out using traditional dry lining. With the Interval system, it took them 34. So 34 personnel days. Because they are coming in stillages, you can actually run multiple games on the same floor, you have fewer people on site, and coordinated significantly quicker. So throughout that, you can see it's a huge saving, a 65% productivity gain, just in personnel on the floor plate, fitting out the same number of wall area on a project. If you come down to wastage though, this is where it's phenomenal. So looking across the floor, The smaller ones are the panelized, just to make that very clear. This is the number of bins and wastage on site. It is a huge reduction, 92% measured waste going to landfill and having to be recycled down the line, compared to traditional dry lining on the right-hand side. This project was a perfect case where the interval system made sense. This is the right time to use it and proceed. Compared to, we know what we love and we know what we know, we'll do what we've always done. Actually, you can see the amount of waste that can come through that, the amount of crews that have to be onboarded, pulled through site, 200 people on a project just doing partition and dry lining. You can see the value by coming into this offsite process and why the interval system is there. So some of the metrics, I'm just going to wrap up here. It's project agnostic type. It can be residential, it can be commercial, it can be hospitals, healthcare, schools. It doesn't matter what's coming into the building. It's an agnostic platform for design. It does optimization, so we can actually make suggestions to a design team. They don't have to accept them all, but it gives them the time to say, 90% of the floor plates are absolutely fantastic. Here are your pinch points. Go and spend your design and engineering hours in those areas and try and optimize it further. If you make some of these small tweaks, it can improve it. You don't have to accept them for whatever reason. You can get immediate bit of material and bill of quants. You can see what you're working with. How does one small tweak impact those values? Significantly faster. It takes less than a minute typically to run these products through the building. Some competitors of ours that are specific to framing and logic, it tends to be let it run, go and have a round of golf, come back, hope that it's actually worked, no errors, fantastic. And we're talking hours to run similar small values to get one initial configuration out. Kope can run hundreds in the background within 5-10 minutes, or a cup of tea or a cup of coffee. You can come back and see what we're working with here as a system. It's outcomes based, we're trying to standardise, we're trying to reduce carbon, we're trying to reduce waste. Each team has a different goal, so we're not forcing you down a single train. It's for you as a design team and a construction team to come up with the best outcome between yourselves rather than one. And the level of insight that you can get is phenomenal within the platform. Individual parts, systems, logic, construction, 3D file to coordinate off the back. That's where we are with Kope and Interval. Hand over to Mr. Cox, and you can go through the second one.
So why is Saint-Gobain really interested in the digital design field? For those who don't know Saint-Gobain, we're a big sort of global company, been operating now for 360 years this year, so been around for an awful long time, and we are really experts in manufacturing components. So we know how to take a bit of gypsum board, set up a manufacturing plant, and really scale that production in a very efficient way. We've already operated in that way in terms of construction components, but a lot of the drivers that are starting to come through into the construction industry are moving away from the traditional manufacture, supply, build model to really get into the nitty-gritty of understanding how we can mitigate a lot of the costs, the skill shortages, the waste, productivity of construction by starting to understand how we can almost take the component level approach to a systemised application. And what we're doing and working with Kope on is to try and understand where the level of standardisation can be driven into systems that is acceptable to the delivery chain. So where can we set that sort of bookend in terms of range of application that will cover 90-95% of the requirements without restricting architectural design and without restricting other routes to market. So it's really starting to think beyond just the product. It's starting to think how can we take the portfolio as we have as a group, pull that together into systems and applications, apply a service to it to give solutions. And we're very aware that a component offer is a component offer, a system offer is just a collection of components. It isn't a solution to a customer. But taking that system and applying the service, which makes it relevant to a construction product, brings you to a point where you're engaging earlier in the design and you're able to influence and give outcomes that often you can't when you're involved later on in the whole design process. So the system itself we're talking about here is Interwall. As Dayle mentioned, I should have had a nice video showing how it goes together, shouldn't I? But it is pretty simple. And the reason we did it on Interwall is purely because of its simplicity. It's got 3 different panel types, so separating walls, corridor walls and division space. The main variable that we're looking to design into the system is the height of the panel. When we first started working on the system, the designer of the system was convinced that this product can deliver everything that traditional dry lining can deliver. And I was very, very sort of pushed back heavily on that to say we don't want to get into that field. We want the level of standardisation, the early design input to allow this system to be designed into buildings early on, rather than try and shoehorn it into a project once it's not really designed around the system application. We then need a service to understand how that can be applied, and what we don't want is what is in those images. What we don't want is rooms and rooms full of consultants and people applying this in the traditional longhand way. So where we want to go is to get to a solution offer where we've got an understanding of the parameters the system can offer which addresses the market we're going to, a service that can digitise the application of that in a very quick way, which you've seen from Kope, to give a solution. And where we really started off, it's a good old Reba process, as everyone likes to go back to, is this technical design stage. Because there's no getting away from the fact, if we design a brand new system and go to a client and say, design your early design concept around a system that's never gone on site before, it's not going to happen. So what we wanted to do is work with Kope to understand the best fit of the system as is to the project as designed today. To see and have those parameters and metrics from the system to say this building can be delivered with 90% standardised panels, 20% non-standard panels. In terms of surface area, that means 95% of the area is being delivered with standard panels, 5% on-site. So is that something that works for you, Mr. Client? If not, we can drop down into a traditional delivery method and deliver using on-site build product. So it was more a case of building a pipeline of projects which are suited to the system, so you don't disprove the system from day one. You get the wrong project and it will kill that system straight away. The second part of the work we've been doing with Kope is to really start to get early involvement to allow people to set out and get metrics to measure their building and understand what the system is delivering, beyond the actual division of space into the value of the whole design process. As Dayle mentioned, there's a lot of figures that chucked out around 92% reduction of waste, 2/3 more productive on site. But when you're looking at in the round, there's huge cost savings in terms of site sequencing, canti-lift operations, crane lifting, waste operation on site, the control of product coming in and being managed at site stores. With these sort of products, they turn up on a lorry, there's 4 stillages for an apartment, which is lifted in 1 lift, and then 4 empty stillages fold flat and come out on site. There's no multiple deliveries from multiple suppliers that are managed and then have to get to the coalface to pay someone to create waste to take away. It's all about the bigger picture, so we can actually say from day one, this is the productivity and value we get from thinking of applying the system early in the design stage rather than fitting it in and not getting the optimal outcome from it. So we went on a big sort of, we have a department within Saint-Gobain, which is a global operation, which is more of a venture capitalist sort of investment arm, and we went off to see who we could work with to design this platform. And they came back, they like to think they came back, but we were already working together with Kope. And from there we invested in Kope, we worked with Kope, and we have got to the point where we are starting to design quite unique platforms that are very relevant to clients, and from all stages down, from the client into the design team, into the main contractor and down, because it's very focused on that sort of top-down drive rather than bottom-up, because a lot of this sort of process is quite disruptive to the traditional route to market, and it may not be the right method. A number of those people are looking to they don't want change. It's just looking at how we can bring a more productive environment to the construction process. This video hasn't got music over it, so you're going to have me droning all over it. So this is real time again. It's a video. It's a project where Dayle, not me, has uploaded a building and started to supply the Interwall system. So this is real time, uploaded, right, let's select the walls. Initially, when we go into drop down, it doesn't locate the walls, and it's one of the things that we are starting to look at early design-wise to name the naming hierarchy of products so it can be accurately located and applied quickly. You see there's a bit of a warning sign. When you look at a separate drop down, it throws in very quickly, when Dayle's typing quicker, over 1,000 walls, and then starts to immediately check out metrics on the right hand side there. So you're starting to get an understanding in pretty much instant time what sort of level of standardisation there is on the build. Early days we looked at number of standard panels versus bespoke panels. We're now very definitely moving away from the panel focus to the area delivered with standardised panels. Because often you find that the infill bespoke panels are little tiny infill bits which are better finished on site for productivity rather than trying to upset the factory operation and the extra cost of bespoke panel. And that's really where the design world meets the manufacturing world. When we get to the level, and we'll look at a case study in a bit, where a third of the panels are bespoke, 2/3 of our factory is non-productive. It's making bespoke panels at a very low level. 1/3 is making 10 panels to every one bespoke that's coming through. So driving that productivity really makes sense, a true PFMA-based approach. And on this, it is basically bringing you into that full breakdown. So you've got a full 3D walk round in this real-time application. You then start to drop into manufacturing drawings, contractor layout drawings, all of the sort of files that we need to create that digital fingerprint of early component manufacture into design, into sub-assemblies, onto site, tagged into place and through the life of the whole project. And this again, going back to Wembley Park, is a case study. It was delivered by CIS. I think there's someone here from CIS. I did see a badge out there that said CIS. But it looked like a good case study in terms of the on-site productivity. So 92% reduction in waste, 65% enhancement in trade use on-site. But behind the scenes, it was very much just one. On-site, we got very good delivery. Off-site, we had 7,000 bespoke panels to make, which was a bit of a nightmare, to be honest, and that's not what we want. So the site itself was committed to working with Kope to get this level of design understanding. And this now, with what we have, if we'd run it, we probably wouldn't have done that site in particular, or we'd have only done component parts of it, the separating walls rather than the internal walls. As I mentioned, 2/3 of our factory were making those 7,000 panels in a very unproductive, wasteful way. 1/3 was very productive, very streamlined, and can very easily get to the level where we can automate the panel manufacture. And then going on into other case studies. So the ability for us to scale and churn buildings to get to that real level of or pipeline of assured product within a range of application is critical to allow us to invest in the infrastructure we need. We're looking at multi-millions of pounds worth of investment into automation, into factories, into distribution, stillages. We're not going to do that with our fingers crossed and hoping the pipeline, the products are going to come through, and it's going to be in a very standardised way. So really getting the early drive of a pipeline that works for the product, which we can really then start to get into the DFMA-based approach to industrialised construction, is key. And we are getting very, very heavy levels of engagement from architectural teams down now. So it's not the other way up, it's people designing the system into the building to push it down through the whole process. And moving on from that, obviously we talked about the division of space using Interwalk, which is a very, very basic system. If that doesn't work, we have a lot of systems with British Gypsum. We have PIM data within those systems. We have EPD data to drive each of the individual component parts. We're moving towards digital product passports. The data that we have on that product is huge. At this point in time, it's not used, but it's very valuable to a building owner and the construction industry as a whole. So if it doesn't work with division of space, we can drop down into a secondary level where we start to optimise the delivery using traditional products around what the client wants, whether it's a waste drive or number of components on site or labour requirements to deliver. We also have infill systems. So when we're looking at big RC frames, infilling external walls, we have systems within British Gypsum and Intrastat where we design the loadings, we have all the fire tests, we have all of the insulation and can deliver from the internal surface right out to the external insulation product, which again, within the Kope platform can be applied very quickly, as Dayle mentioned, and starting to make links with other software platforms, the likes of Tetla, the likes of Autodesk, so we can actually really make the product usable within that design field. And then we have full structural systems as well, so full light gauge steel frame panels, which all have data sets that can be applied within a digital platform like Kope. And then the what next side of it is, if you nail the first point of early design engagement, optimising, designing out waste in design, in manufacturing, on the on-site side of things, and the delivery, how does that data and the fingerprint that's been created for that project become usable for the building owner? So design covered with Kope, production digitised, Kope kicking out CAM files that work within a complete digital architecture, connected through into the install and delivery. So tagging products in place. At the moment we do not, or we're unable to track and trace individual component parts. When you have a sub-assembly at the level of a panel, it makes total sense to start to apply RFIDs or QR, individual identifiers, to make it usable through life. And to get to that critical piece everyone's looking to get to, which is the end of life, so that extra 8th Reba stage around end of life, circularity and reuse. So we can start to design in the construction field around, at worst, recycling the components at end of life, at best, reusing those components at the end of life, and in the middle, sort of reinstating and refurbishing those products. So there's less of a manufacturing demand on a product at the end of life, so to create that more circular and sustainable approach. To really get to that sort of resource management piece where we know we can as an industry. And just finishing off, the industrialised construction paper was released by Porsche Consulting last week in conjunction with Autodesk. It's well worth a read. It's really looking at that simple equation down the bottom of understanding the productionisation, so the standardisation and configuration of component parts, the DFMA-based piece, so how can we bring that into a manufacturing environment and make it usable and investable, really, and then the prefabrication, physical output of it to get to a true industrialised construction model. And that's where we are in terms of our journey so far. Very interesting, very data-driven, and very different to our business as usual.